Hello everyone. Today we will discuss about Ohm's law. Ohm's law is a topic from electricity chapter of class 10th, and here we will understand about it. So watch this video till the end to understand about Ohm's law, and you will also get to know about the resistor in series and the resistor in parallel. So here let's look at the definition of Ohm's law first of all. So according to Ohm's law, the potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. So we have two things. One is potential difference, which is V, and another is current, which is I. When the George Simon Ohm, when he calculated the potential difference in current, he found out that with increase in the value of potential difference, with increase in the value of current, the potential difference is also increasing. So accordingly, he found out that both of them are directly proportional to each other. That means potential difference V is directly proportional to current I, which implies V equals to IR. Because when you remove any proportionality sign, you have to put a constant. So George Simon Ohm, he put a constant, that is R, where R is a constant. Now moving forward, we will understand about the factors which will depend on any resistance of a particular conductor. Suppose we have a conductor, and in this particular conductor we have L is the length of the conductor and A is the cross-sectional area of the conductor. Now in this particular conductor, the length of the conductor L and the cross-sectional area of the conductor, which is capital A, and nature of its material, these three things will depend on the resistance of a conductor. So how can we represent it? First of all, we will write resistance R will directly proportional to length of the conductor, that is small l, and R is inversely proportional to cross-sectional area of the conductor, that is capital A. When you combine them together, you will get R is directly proportional to L by A. So if you remove the proportionality sign, you will get a constant which is rho. Here this proportionality sign is rho. So R is equals to rho L by A. Now we will talk about the resistance of a system of resistor. There are two methods of joining the resistors. We have resistors which can be joined in series, and another is we have resistors which can be joined in parallel. So first of all, we will look at the resistors in series. So when we look at the resistors in series, you can see how the resistors can be connected in series. We have three resistors, that is R1, R2 and R3. They are connected in series, and by using a battery and ammeter and key, so once you join them, first of all you have to understand what is the definition of it. So the definition for a series combination is a series circuit is one in which numerous resistances are linked one after the other. So we have the first resistor R1 which is connected to the second resistor R2, and it is also connected to third resistor R3, and it is connected in a series circuit. So how do we find out its explanation as to what is the equivalent resistance once we want to find out its equivalent resistance? So if we have three resistors, that is R1, R2 and R3, and when they are connected in a by using a battery and an ammeter and a key, and if the potential difference across the resistors are V1, V2 and V3 respectively, then we will get, first of all we have to consider the three resistors R1, R2 and R3. They are connected in a series. The potential difference generated between the resistors R1, R2 and R3 are V1 and V2 and V3 respectively. So the total potential difference across the three resistors must be V equals to V1 plus V2 plus V3. After that, we have to keep it as equation 1. Now, if I be the current flows in the circuit, then according to Ohm's law, we can write V equals to IR. This was the thing which we have learned according to Ohm's law. Now applying Ohm's law on three resistors, since we know that the first resistor is R1, the second resistor is R2 and third resistor is R3. So if you find out the potential difference of the three resistors, then we can write V1 equals to R1 plus V2 equals to IR2, V3 equals to IR3. And if we want to substitute these values in the equation 1, that is v equals to v1 plus v2 plus v3. That was the first equation. And if you substitute the value of v1, v2 and v3, that is r1, r2 and r3, then you will get v equals to ir1 plus ir2 plus ir3. Now after that, if you do further calculation, that is ir equals to ir1 plus ir2 plus ir3, and if you take the common, I is common, then you will get ir equals to ir1 plus ir2, r2 plus r3. So here if I and I both will cancel, then you will get r1 plus r2 plus r3. This is the required equivalent resistance of registers connected in series. So this was the particular explanation of series connection. We will take another video for completing the parallel connection. Okay, so that was all. Thank you so much for watching.